As I have said, I have already discussed the logistic regression. I have some introduction from the last week's synchronous class, and today we're going to discuss about three methods. Okay, so the mathematical portion, or if you want to know more about the mathematical concepts behind the decision tree and the random forest, these are all covered in the chapter 8 of the Introduction to Statistical Learning by Garrett James. Okay, so in case that's just what you'd like to know more about the mathematical concept. So let's start off with a thought experiment to give some motivation behind using tree method. No? So here in the presentation, let's try to imagine that I play tennis. No, actually, I'm not playing tennis. I am into other sports. Okay. Let's try. But imagine that I play tennis every Saturday, and I always invite a friend to come with me. And sometimes my friend shows up, sometimes not. And for him, it depends on a variety of factors. For example, uh, my friend will go depending on the weather, the temperature, humidity, wind, and others. Okay, so I start keeping track of these features and whether or not he showed up to play with me. Now, looking at this data, you can see in the first day, my friend came. No, he played because of the outlook, which is sunny, and the humidity is 80, and the windy is no. It's yes or no, and also the temperature is mild. But on the second day, however, the temperature was hot, although it's sunny, and the humidity is 75, and it's windy. My friend did not came and did not play. Okay, and so on. As you can see from the data set here. Okay, so I want to use this data, the data set, to predict whether or not he will show up to play. And an intuitive way to do this is through a decision tree. No? So as you can see from here, okay, in this tree we have nodes. So nodes are split for the value of a certain attribute. And also we have edges, which are the outcome of a split to next node. So you can see from here, we have a root. No? The node that performs the first split, which is outlook, and the outlook is splitted into three. Okay, namely sunny, overcast, and rain. And also we have what we call the colored ones, no? The yes and the yes no. These are called terminal nodes that predict the outcome, whether it's a yes or whether it's a no. Okay, so the humidity and windy are also root here, no? As you can see. Now, to be able to understand the three methods, let's try to discuss about the intuition behind the splits. You know, how do three methods um, split the decisions? Okay, so this is an imaginary data with three features, namely x, y, z, and they are with two possible classes. For example, if all are ones, and that's going to be class A. If x and y are 1 and z is 0, that's still class A. However, if if x and y are zeros and z is 1, that's going to be B. So you can see from here that the more ones they have, that's going to be class A, to classified as A. But if there's only one, or the more zeros they have, no, in terms of x and y and z features, its class can be categorized as B. Alright? So basically, that's the intuition behind the split. So splitting on y gives us a clear separation between classes. No? As you can see from here, if y is equal to 1, it can be splitted whether it's a yes If it is yes, it's classified as A, and if it is a no, it's classified as B. So therefore, from here, if Y, okay, because you cannot clearly separate the classes in terms of X, but in terms of Y, there is a clear indication that if it is Y, it can be categorized as class A. But if the Y is 0, it can be categorized as B. Therefore, um, the intuition behind the split is that we can look on, or the algorithm looks on the data where the split can be clearly separated between classes. No, like for example, in this case, it cannot use X as a feature or identifier for let's say class A or class B. We cannot also identify the C based on the features that are present here. No, for example, if X is 0, it can be B, or if X is 1, it can be either A or B. But clearly, when you look on the split on the Y, if Y is 0, it's clearly B class, and if Y is 1, it's clearly A class. Okay. Looking on the Z data, it's either A or B if it is 0, and it's either A or B if it is 1. So definitely, we could try splitting all the features, but you can see from the features who's gonna decide which one definitely categorize the two classes in the example. Okay, so this splitting, okay, the intuition behind this split is actually done using a mathematical method, no? And this mathematical method is what we call the entropy and information gain, which are the methods for choosing the best split. Okay, so if you want to know about the formula, okay, so about entropy and information gain, here are the formula. But if you want to know the mathematical concept behind that, you can refer to the book, no, which was given here. Okay, now so that's behind the concept of a decision tree. And actually, when we try to dig deeper, no, on how we can understand the decision trees and random forest, there are many references out there, no, explaining about the concept of decision tree and random forest. Like for example, another analogy that we can give, aside from playing tennis with my friend, whether my friend will come or not, okay, depending on the features of temperature, humidity, wind, etc., etc. Okay, so another logical idea is, for example, let's imagine you are at the library, no? Some students do not come to the library very often, no? When I was studying, I used to go to the library and sleep there. Okay, now imagine you are at the library and you are trying to decide on a book to read, no? Say you want to read a book. So luckily your friend, for example, the name of your friend is John or Jonathan. Okay, your friend Jonathan is with you to help you decide. Okay, so basically we're talking about decision trees, no? And decision trees are a series of splits. So whether you're going to the right or you're going to the left, what choices or decisions you're going to have. Okay, so Jonathan begins by asking you, your friend Jonathan asks you to ask you for a list of books, no, that you have already read, no, and whether or not you enjoyed them. no? And that is what we call in machine learning, we call that, we try to train set with labels, okay? Because we are asking for the books that you have already read, no? So basically, meron ng idea si yung friend mo, what are the books that you have like or not, okay? Then you pick a book, for example, from the shelf, and your friend begins asking you questions to determine whether or not you'll enjoy the book. So your friend asks you yes or no questions, okay? And there are also other questions such as who is the author, what year was the book written, and sometimes he will ask you about some informative questions, okay? So those informative questions in machine learning is what we call maximizing information gain, no? So here's the formula in order to maximize the information gain, okay? And then finally, after getting some information from you, your friend now tried to give you his yes or no recommendation on the book at the end, no? Okay, so that is what we call classifying the test set, okay, in machine learning. So we can now classify whether the book will be a recommendation for you, whether it is a yes or no, okay? However, your friend Jonathan is just only one person, okay? So imagine, and his and for example, if I am your friend and my question sometimes hone in too much on a particular book, for example, depende sa gusto ko, no? So the term for that is what we call overfitting, okay? Because it is honed in too much on a particular book that I like, for example, and that is what will I recommend because I like it, no? Kumbaga bias, okay? Now, to get a better idea of whether or not you will like the book from the shelf, so you ask several friends through the same process, okay? So, and they each give a vote on the book, and you decide on the majority opinion, and that is what we call a an ensemble classifier. Okay, an ensemble classifier in machine learning means you're trying to get opinions or decisions from the majority opinion, no? So for example, it's like which one is the best way going to Tagaytay, no? So you ask your friends, and then from those decisions, from the answers of your friend, you're trying to understand the different answers, and then from the answers, the majority of the answer, for example, the best way is by via Santa Rosa, for example, or via Macapagal Highway, etc., etc. Okay, so those majority opinion, or what we call in machine learning the ensemble classifier. Okay, now if you have a similar circle of friends that may for example have this exact same process of questions, so to avoid them all having the exact same answer, you'll want to give them each a different sample from your list of books. Okay? And you decide to cut up your list and place it in a bag, then randomly draw from the bag. Okay? So we're talking about random forest here. Okay? So you randomly select, okay, from the bag and tell your friend whether or not you enjoy the book, and then place the sample bag in the bag. Okay, and this means you'd be randomly drawing a sub-sample from your original list with replacement. No, this is what we call in machine learning. We call it bootstrapping your original data. So that means you're randomly drawing a sub-sample from your original list with replacement. And this gives some book more emphasis. If you drew a particular book several times, for example, for one friend, and some books less, and possibly never drawn from the bag. And then each individual will give a unique recommendation on your book preferences. Okay? So now your friends now form a bootstrap aggregated forest. Okay? And however, we still have some issues to handle, no? For example, imagine you enjoyed a certain book, no? For example, Harry Potter, and the other one is a science fiction book, for example. Okay, and there are several likings or several things linking those books or the same author, similar genre, and typical year where when it was written, no? And one of your friends may come to the conclusion that you enjoyed both books, no, although they are different, no. The first one is a science fiction, the other one is magical, for example. So when in reality, and those books, for example, are written in the same year, no. So we can fix this by introducing some randomness, no, and that is the concept behind the random forest, no. A randomness is introduced at each node of the decision tree. You randomly select the attribute to split on, no, and it's very important to note that when we try to induce randomness with the data, we do it using what we call, the term is bootstrapping. Okay, and you are introducing it into your actual model. Okay, now in terms of random forest and decision trees, there are also what we call pros and cons when we talk about the decision tree, no. For example, for the pros, okay, decision trees are easily interpretable, no. When we try to code a decision tree, it's interpretable and can handle missing values and outliers. They can also handle discrete and continuous data types along with irrelevant features. However, for the cons, decision trees can be very easy to overfit. And while they are computationally cheap for prediction, training the decision tree can be computationally expensive. No? For example, if you have a very large data set, it would be computationally expensive. Okay? Now, talking about random forest here, no? So, decision tree, actually random forest is a improvement of the decision tree method or model, no? And in random forest, we try to improve the performance of the earlier model wherein we can use many trees because yung decision tree is just a single tree decision, no? Single decision tree. However, in random forest, we are using many trees with random sample of features chosen as the split. So definitely in random forest, this is an example of an ensemble method in which we combine multiple machine learning algorithms to obtain better predictive performance. Okay? And actually, we are running multiple models on the data and use the aggregate prediction, no? So we can use a new random sample of features for every single tree at every single split, no? And as I've said, we will run multiple models on the data and use the aggregate predictions, which will be better than a single model alone. Okay? Now, random forest is one of the most common uh, ensemble method, no, which consists of a collection of decision trees. So basically, random forest is a collection of uh, uh, random trees. Excuse me. Okay. Now, um, what's the point on using the random trees? No. For example, suppose there is one very strong feature in the data set. No. And when using bug trees, most of the trees will use that feature as the top split, no, resulting in an ensemble of similar trees that are highly correlated. So when we say correlated, so the when we say highly correlated, it we're talking about the dependence, no, of the data to one another, no. Now if a feature is very strong, no, in a data set, it will definitely influence the other, no. So basically it will be called uh, highly correlated data. Okay. Now the idea behind that random forest is actually pretty simple. Okay. So actually we are just repeatedly selecting the data from the data set and build a decision tree with each new sample. Okay. And it's important to note that since we are sampling with replacement, many data points will be repeated. Okay. And many won't be included as well. And the most important thing to keep in mind when we talk about measuring error of a random forest is the feature is that each node of the decision tree is limited to only considering splits on random subsets of the features, no? So if you try to average highly correlated quantities, actually it does not significantly reduce the variance. So by randomly leaving out candidate features from each split, random forest decorrelates the trees such that the averaging process can reduce the variance of the resulting model. So this is what the random forest do to prevent highly correlated features of the data. So in the case of, for example, classification, we use each tree in our forest to get a prediction, no? So and then the label with the most votes becomes the predicted class for that data point, no? Yeah. No, if you remember my example about the library, the most voted decision from your circle of friends, for example, will be chosen as the most recommended book for you. Okay. Now the predicted class for that point, for example, in the case of classification with random forest, we use each tree in our forest to get a prediction, and then the label with the most votes becomes the predicted class for that data point. Okay, and the usual parameters when we try to build the forest is in the scikit-learn library, or we call it sklearn, no? And there are 10 trees. Actually, there are 10 trees in random forest, and only considering the square root of n features, no? So here we have an example here, no? For classification, m is typically chosen to be the square root of p. Okay, where actually m is the total number of features. Okay, now in terms of determining error, no, if you want to know how well our random forest performed, we could use a standard cross validation, no? Later we will have some example of that we will use standard cross-validation method of splitting the data into training and testing set, and then compare the predictions to the actual values. However, as I mentioned earlier, each tree doesn't get a chance to see all of the training data. Okay? So the unseen data can be used to cross-validate each tree individually. Now, when you select from the data set, no, usually it's about 1/3 of the data is left out. So the mathematics behind this are actually in the entropy and information gain. No? So in the statistical books that I mentioned earlier. Now, if you try to calculate the percentage of these data points with the correct prediction, we get the out of the bug error. No? Actually, the out of the bug error is sufficient in judging the performance of the random forest model. Okay? So let's try to proceed, and maybe we can actually show an example of decision tree and random forest. But before that, as I have mentioned, we'd like to have logistic regression example first, no? Because in your activity, there are 3 topics, no, that you will have to consolidate in one activity, and you'll see that later, no, when I show you your activity. And the 3 topics that you will have is the logistic regression, decision trees, and random forest. Right? So let's try to open my Jupyter notebook. Okay, so I think you can see my Jupyter notebook. Alright, so let me open my documents, and from my documents I have predictive analytics using machine learning, sorry. And then I will create a new Python notebook here. Okay, so I'll just make it bigger. Okay, so the topic that we will discuss, or I'm going to show you first the logistic regression example. Okay, and in this example we are going to use the famous Titanic data set. No, you all know about Titanic, right? Who hasn't watched the Titanic yet? So Titanic is a disaster in the year, I don't know what year is that, 1800s or early 1900s. Anyway, and that is a big, one of the biggest disaster in maritime industry, where many people have died, no? And we're going to predict using logistic regression whether a person or is survive or not. Okay, so to be able to do that, let's show how to import. So let's try to import first our libraries. So let's try to import pandas as pd, and then import numpy as np. Okay, so let's run that, and let's try to import our visualization packages. Okay, import matplotlib.pyplot as plt. Okay, and also let's try to import seaborn as sns, and then to be able to show the plots in our Jupyter notebook, let's use %matplotlib inline. Okay, and then let's run that. Okay, and then let's try to create a variable called train. This is for the train, and then let's use the pandas to read the data set. Okay, so do I have the data set? So let's have the data set. I think the data set is here. I'm going to put it here. Okay, so let's name this as module 3 notebook. Alright, so let's try to use the Titanic train dataset. Okay, and let's look on our data. Let's examine the data. So as you can see from the data that we have, so the columns are actually, if you try to check on the different columns, we have passenger ID. Actually, the passenger ID here is in sequence, no? And it's not actually starting in 0. So when you look at the tail of this data, you will see that it's just the same as the, and when you look at that, you are not going to use this column, no? Now, right now we're analyzing the data set, whether we are including this column for our machine learning, no? For our logistic regression algorithm or model. Okay, so definitely we cannot use the passenger ID, but we can use the survive, no? So the survive is telling us whether 0 means the passenger did not survive, and 1 means the passenger survive. Okay, for the P class, so this is the passenger class, so we only have 3 classes. The first class belongs to the rich people, the second class in the middle class, and the third class are all for the cheap price, no, cheap fare for the Titanic. Okay, and then we have the names. So definitely the names will not be used, no, because these are all it's difficult to for the machine learning model to represent these strings. And then of course the sex, we can use an approach on how we can use the sex, the gender, whether it's a male or female. Maybe we can use 1 for the male and 0 for the female, and we can use that using a function called getDummies. I'll show you that later. And also we have here the sibling sib sp. Okay, this means that whether or not you have someone with you, no? The passenger has someone, like for example a wife, a child, or a husband, a sister or a brother, etc., etc. And then we have the parts. Now I don't know this parts, but it definitely gives us some values here, like for example zeros and ones, etc., etc. Okay, and then of course the ticket is a combination of integers and some letters. So definitely we cannot use this as a feature for our machine learning model. Okay, definitely fare is okay. Okay, the cabin is maybe we can also drop the cabin, no? We can remove the cabin because it's a combination of a character and numbers, and we cannot use this, no? The embark can be used, but we have to convert these features into a zeros and ones, no, later. Okay, so that's how we can examine. Now let's try to examine, let's explore more the data by checking whether we have some null values Okay, so maybe we can see train is null, so we can see how many values are null or not. So we can see from here we have the following columns, and when we see some columns here, it's false. That means that that is not a null value. But you can see from the cabin, when you see true, so there are lots of uh, values that are true. That means that those are null values, no? Similar to the none cases here, no? But also there are also some values here. For example, in the age, no, you can see from 888 that the age is not identified. So definitely there is a problem when we talk about the train is null, no? If you want to take a look at the heat map, no, so we can use this, okay, and we can use a heat map, for example sns.heatmap, okay, and we can use this data, okay, we can use that data for our heat map, no, by by using the Seaborn's heat map, and then we use the data that we would like to include in our heat map, and definitely we'll try to use the y-tick labels, and let's identify that as false, okay, and we'll also use the C bar but identified as false, and then we can use the C map, which is equal to Viridis. These are just some features. Now if you want to know more about the heat map, you can use the shift tab features, or and that, so you can see the different features, no, that are available in the SNS heat map function. Okay, so that one you can also make identify the different for example, what are x-tick labels, y-tick labels, etc., etc. So we can do that by inserting our mouse inside the function, no? If you don't know the parameters that you will use, you can just use shift tab, okay, so shift double tab, and you can write all the things that you want here depending on the parameter that you would want to use. Okay, now let's try to execute this so that we can understand the concept behind. We're looking on the false and the true values, no, so whether those values are null and not null. Okay, so let's try to execute this. So we can see from the heat map, okay, say basically we're this is a different type of heat map, and we only have actually two colors here, no? Okay, because we have ticked the y-tick label as false and the C bar as false, no, so therefore we shall have two colors, no, and the yellow colors that you see here are the values which are true, no, meaning these are null values, no, and you can see that they are in the column age, around the 20% of the column age are absent, okay, so they are not present or null values. However, in the cabin, so majority of the contents of the cabin doesn't have values, no, they are all null values, no? Only a little percentage has information about the cabin. Okay, so that's how we can see, no, so therefore the cabin has too much information that is missing, no, meanwhile the age looks like around 20% of the age is missing. Okay, now let's try to examine more about how many passengers, for example, how many passengers survive. Okay, so we can do that by using the Seaborn's count plot. So we're trying to plot and count at the same time. Okay, so we can use the x-axis, and we will use the x-axis as those who survive, no? And we will use the data. The data will be used is the train data. So let's try to plot this one. So this is the values that we can obtain, no? So but there are no lines here, no? So maybe we can use we can set the style, SNS set style. So this is it, and then we will put some white grid. Okay, so that we can have a very nice plot here, no? So from the illustration here, we'll see that between zeros and ones, so these are the number of people who survive. However, these are the people who have perished or died in the Titanic. So more than 300 are accounted to be dead. This is just some example of the data set, no? For the train data set that we have. These are not all the data set from the history of the Titanic. Okay? So, but definitely the zeros here survive. Okay? Did not survive, and this yellow here survive. Okay? Now, in terms of, for example, what are the, if you want to know more about the what are the genders of those who survive and those who did not survive, so we can use also the same, but we will add additional information here. Like for example, we can use the U as the gender, no, or the sex. Okay, so now we are counting those who survive, and at the same time we're also counting the gender of those who survive and those who did not survive. Okay, so yan. So we can see here that majority of those who did not survive are male, only few are female, and majority of those who survive are female also, and because the female has more numbers than the male. Okay, in terms of class, let's see whether what class those who survive most, no? Sino ba yung mga namatay, mga nasa first class ba, second class ba, o nasa third class? So let's try to identify. So we can use also this one, but we can replace the U with the P class, no? So this is the P class, and we can identify that those who are in the third class are the ones who did not survive. Okay, and those who survive are those, majority of that, actually it's not that majority in terms of, but in terms of those who survive, those who are in the first class survive more than the second class. Okay, second place lang si third class here, no? Okay, now if we talk about the age, for example, no, so maybe we can identify those, or we can use the count plot or distribution plot of those, for example, we can use the distribution age of those who are in the passenger list, no? For example, we can use the seaborne, then we use the dist plot. Okay, and of course we have the data, and we can use the column age, and you can use drop NA, okay, function, and KDE is equal to false, and the number of bins, for example, is equal to 30. Okay, let's try to check. So here's my problem, no? Okay, that's okay. Still there's a problem. Okay, here. Okay, so this is the distribution plot of the age, no? So you can see from the distribution, in terms of age, majority of the passengers are in between 20s to 30s, no? Because those are the number of counts, no? Number of counts. So majority of those passengers are in this particular age, no? We can also, because this one is not that very nice to look on, so we can create another way of doing that. So maybe you can use train age, okay? And then we can plot the history or the hist. So I think we will have some error here later. And the number of bins, for example, is equal to 15. No? Now we can check now more clearly the age of those in the line of 20s. So in terms of how many passengers are in their 20s to 30s, so these are all the numbers, no, of passengers. Okay, now looking on the passengers, or how many, if we try to look on the passengers, how many of them, let's try to count how many of them using the SIB-SP. The SIB-SP is a column where we will ask, or we would like to identify whether a particular passenger has someone with him, no, or her, no, when he embarked the Titanic. Okay, so we'll use the train data, so we can count plot how many passengers have SIB-SP. Okay, so from the data we all know that it's either zeros and ones, no? So we can actually count the number of people, no, who has no one with them, no? So we can see from the figure, majority of the passengers, almost 600 or 600 in the total number of the samples that we have for the data set. Many of them do not have someone with them. Only 200 has someone with them. It can be a father, a mother, or a daughter, a son, or a brother or a sister, etc., etc. Okay? So, yan. So, kung dalawa yung kasama, only this amount. Kung tatlo yung kasama, only this amount, etc., etc. Okay? Now, in terms of fare, so we can use the fare, no? For example, train. Okay? So we can check the hist of the train, okay? And the fare, sorry. So let's say the bins is equal to 40. So this is the fare. So we can check the fare. Okay? So majority of the price, no, definitely in terms of fare, you can see that the majority has this particular price. So definitely, because we can see from the number of passengers in terms of classes, majority is in the first class, no? So the higher the fare is, the more number. This is the highest fare, is almost 400 in terms of dollars, maybe. So these are the people who are in the first class. So you can see the fare is going down here, no, in terms of the now if you want to to include a visualization, no, for a more interactive plots. So have you ever used about cufflinks? Okay, so you can import the cufflinks, and if you don't have cufflinks, no, for example, you will have a problem running this. In the first time that I run this, I have to install cufflinks first before I run this, no. So we can import the cufflinks, and then we can use CF or cufflinks, and then go offline. So because there is an online version of this, no, so we can go offline, and then after that we can use this. We can copy this command and paste it here, but we need to change the hist to iplot, no. We're using beans is equal to 40, but we can include here what kind of we will use the hist, no, instead of other concepts. So what is the purpose of this cufflinks? So we're using cufflinks here, or iplot, to plot our fare, no? So this is more interactive plotting. So you can see from here, so you can export this, and you can also zoom. For example, if you want to zoom this, you can use box select, and then you can actually try to zoom in a particular and this is box select, and then you can zoom. Okay, you can actually zoom for a particular and you can see the details, no, when you click on something, no. So you can also zoom. For example, you can zoom here, yeah, and to get a clearer view, because we already zoom it, no? So if you want to reset, you can just auto scale to go back to the things before. Okay, and you can also download a plot using as a PNG, no? For example, here, yeah, that's the new plot. So this is the plot that we have created, no? You can also do many things in cufflinks, and not only this type of this is just the hist or the histogram, right? So we can do many other things, no? This is just to show us. Okay, now let's try to identify now more examination on the data that we have for the Titanic data set. Say we have the let's try to use a box plot, no? And for the x-axis, we will use the class P class, and for the y-axis, we will use the age. Okay, and then of course we will use the train data. Okay, so let's try to identify in terms of the classes, no? So we'll try to know how many people are in the first class, now what ages are in the first class, what age range are in the second class and in the third class, no? So this is the result of the command. So we can identify now that actually the majority of the passengers are in the first class. However, looking at the age of the people in the first class, majority of them are in their 50s, no? The maximum range is in the 50s. So it's between 27 to 50, and the middle is in the somehow in the 37 or 38 or 39, something like that. Also in the second class, which falls second from the so this one is logical, no? people are in the first class are the rich people, no? And to be able to become rich, no, you'll have to come with age. There are people during that time, they can only amass wealth when they are, for example, they have reached a certain age. Now, what we're trying to do here is we're trying to clean the data that we have, because there are lots of data to be removed in our data set. No? Looking back on our data set, so there are many things that we would like to remove here, no? And there are things that we will retain, but we'll need to convert them using other formats. Okay. Now, the process of for example, in terms of age, you know, definitely we would like to do something about the age, no? Because looking at this heat map, in the column of age, there are 20% of them. Okay, 20% of them are absent, no? Meaning null values. So what do we do with those null values? We need to fill in information. No? We need to fill in information about this. No? And we will use the data that we obtained here. So from here, we can see what is the mean or the average, no? Age of the first class, the second class, and the third class. So definitely we can now use the average for what we call the process of amputation. And amputation means we would like to fill in values, no? Especially null values. So we can actually create a function to do that. So let's try to create a function. For example, define impute age, and we'll use the columns for that. So the age will be equal to the columns for the first column, and then we will use the p class also for the columns, but for the second values. Okay, now let's try to understand if PD is null, okay, for the age. Wrong spelling, should be. So definitely we will do something about this, no? If the age column has a null value, okay, so we would like to if it is a null value, we'll do something about this, no? For example, we will create another loop inside, no? Another statement inside that if P class, okay, if P class is the first class, so what we will return? So we will return values in the middle, no? So definitely somehow it looks like 37, no? So that's 37. We will return an age of 37. So definitely when the program will have to see if it is a null value and the passenger is in the first class, we will just say that we'll just fill in with the average, with the mean value, which is 37. But if the passenger class is in the second class, okay, we will return a value of, which one is this? So this is around almost 30, which is, let's say, 29, okay? And if the passenger class is equal to the third class, okay, so we will have to return a value of, definitely that's around 24 or 25, or it's not 25, it's around 24, okay? Else, so this will be the else for our outer loop, okay? So we will just return the age because we already know about the age. So we can run this, okay? We can run this now. So this will be we're doing something here, no? We're doing something for the, actually this is just a function. We did not do anything yet, no? But here, in our column, uh, age, no, we'll do something about this. Okay, so we'll try to use the same, uh, data. Okay, but definitely we would like to use age and p class. Okay, and we will try to apply our function, no, and our function is called impute age. Okay, okay, inside the impute age, we'll try to replace that using the first column. Okay, axis is equal to 1. So definitely what we're trying to do here is to apply our function here, which is impute age. Okay, this one, no, this function, and this function tells us that if the age is in the first class, no, so we're trying to use both the columns of the age and the p class and apply this using the function here that we have created, and we will try to replace all the information in our age. Okay, so definitely this will be the case when we do that, no. So let's try to apply this. So it's already applied, so we can now check. Okay, so maybe we can just copy the code here. So we can copy now this one, and let's try to see and check whether we have applied the function that we have created. Oh, you can see from here there are no more null values in terms of age, no. However, there are still some values missing here, no, for the cabin, because we did not do anything. But for the age, we apply the process of amputation, no. We fill in values of the mean values of the first class, mean values of the second class, and the third class, no, which are 37, 29, and 24. Okay, that's how we can do that. And then of course, to be able to see, no, because we will not use cabin, we can actually drop the cabin, no. So let's try to drop the cabin. Okay, so we can drop the cabin, and to be able to do that, we will use axis is equal to 1, and then in place is equal to true. Okay, so now that it's already, we can now check it again. So we can copy and paste that, and then check, no. So there are some missing values here in the embark, no. So definitely it's negligible. Okay, so we can now, you can try to remove that, no, later if you want, no. For the purpose of demonstration, we'll try to leave it as it is. Okay, now looking on our train, okay, data set. Okay, so you can see from here that we have removed the cabin, no. We have removed the cabin, and all of the age now has its own values, no. But you will notice that we can try to remove some values here, no. And looking on the, for example, in the column sex. Okay, so we can convert the column sex into different values by using the pandas get dummies function, wherein we will use the column, which is sex, no. So executing this, we'll have some information about the the column sex, no, where the female is equal to 0 and the male is equal to 1, no. So definitely when we try to use this, the values for the male or the female are converted into binary, no. It's either 0 or either 1. Okay, so but definitely we will not have to retain, or we will not implement this in our machine learning model, because the machine learning model will actually identify, no. So maybe we can remove one of this column. We can just retain, for example, male, no. If it is a male, it's 1, and then if it is a 0, that definitely is a female. Okay, so definitely we can actually drop, no, the. And how do we do that? We can do that by, for example, using the get dummies option, and then we will use the train for the sex, because we're trying to do that, and then we can now drop the first value, okay, which is equal to true, and then when you try to execute that, we have removed the value for our female. Okay, so looking on the sex dot head, for example, so we can have, actually we can actually use this for our sex, so that we can have a data set called sex. Okay, yan. So looking on the sex data head, we can see that we have ones and zeros for the male, no? Now, getting back on our train data set, no, looking on the embark, we can do something also about the embark. Okay, but actually the embark has 3 categories, no. It has S, and you can see here it has C, and there's another letter called Q, no. So looking on that, we can check embark. Okay, say embark. Okay, and let's try to use the get dummies option, okay, for the train, and then we'll use the embark column. All right, so, and then let's try to use the embark. Okay, yan. So you can see from the embark, we have 3 categories, as I have said. It's either C, Q, or S, and they have the following values. So we can remove, actually we can remove those values. For example, we can remove the first one, no. We can drop the first value. Actually, we can do it here. Okay, we can drop the first value, set it to true, so that we can only have the two values, which are Q or S. Okay, yan. So that we have that, no. Now looking on the our how do we apply it in our data set? So maybe we can use the data set train, and we can just concatenate, no? We can just concatenate the values that we obtain from the train, sex, and embark. Okay, so from the embark, sex, and the train, no? Here we have the train, no? Oh, we have the train. Okay, so we'll just concatenate everything here. Okay, and we can use the axis is equal to 1, and that's it, no. And then we can check now the contents of our train. Okay, let's see. So you can see from here we have a combination of sex, okay, but we also have a male here, no. And we have the embark, Still, we have the embark. We haven't dropped the embark column, but we have the Q and S. Excuse me. I'm sorry. I'm sorry for that. Okay. Now it's time to drop everything that we don't need here. For example, we can drop the passenger ID. Okay. We can drop the passenger ID because the ID is just telling us about the order of the passengers and starting from 1 up to the end of the line. Okay. So we can retain the whether they survive or not. We can retain also the passenger class. We can also but the name, no, definitely we can remove the name, no, and sex can be removed because we already converted it into a get dummy option. We can remove the ticket also, and we can remove the embark, no? So let's try to drop those. Okay, let's try to drop everything. So what are the things that we will drop? The passenger ID. Okay. We can also drop the sex. Of course, we will drop the name, no? We don't need the name. And then we will drop the embark. Okay, sorry for that. Okay. And then we can drop the ticket. Okay. Okay, once we drop that, we can also use the train that head so that we can understand what we have done, no? Okay. So this okay, sorry. There is an error here. Not found in the axis. Okay. Okay. So there are missing commands here that we should put. For example, axis is equal to 1, and we could also in place is equal to true. Okay. Okay, so this is now the content of our train, no? When we remove, do you think it's okay now for to be able to use it for for our um, training for the model that we would like to use? I think it's okay now, no? But for the meantime, we pause for a break, no? 10 minutes break. Let's have a break here. So try to resume our recording. Okay, let's go back to our notebook. So it's time to train the data. Now that we have the clean data, okay, we have the clean data now, so we can actually split the data into two. We can use the X, and in splitting the data, we have the X and Y, wherein the Y values is the um, what we're trying to predict, no? And we're trying to predict whether the passenger, sorry for that, the passenger survive or not based on the uh, multiple features that we have. Okay, and for our X, we can use also the train, but we will just try to drop the survive column. Okay, so we'll try to drop the survive. Okay, of course, and we try to drop that, we need it like this, no? So okay, so that will be our X and Y. Okay, and then we can use the sklearn model selection. So we will try to import that sklearn, that model selection, and then we will import the train test split function. Okay, and let's try to import that. Okay, for our X train, um, actually we can use the train trace split function. So from here we can copy the, actually we can copy here the default template of that, no, this one, which is this one. We can copy this and we can paste it here. Okay, so we can also remove this. So we can also change the random state, because this one is the default, no, or you can use just the default, no. We can remove this, and let's try to have a 0.3 size for our test size. Okay, or maybe we can use the random state. Okay, we can use the random state, or we can just leave it like that, no? And then after that, of course we need to run that, and we'll now try to import our logistic regression, no? So from sklearn, that linear model, that's a linear model, we'll try to import logistic regression. Okay, and then let's run that, and let's create a model. So we call it log model is equal to logistic regression. Okay, let's run that. Okay, for fitting, we can actually use the log model that fit function, no? So now if you want to know more about the fit parameters, we can use the double shift tab. Okay, single shift double tab, and you can actually see here what are the things that you should actually provide in the parameters. So definitely we can use x and y. Okay, and our x and y here is the x train. Okay, and for the y, we can use the y train for training the model. Now this is to train the model. So let's try to run this. So you can see from here, this will be the output, no? So meaning that we have already fit or trained the model using the following parameters. Okay, these are the default parameters for the logistic regression, no? For the predictions, we can create a variable called predictions, and we can use the log model to predict, and of course we will use the x test, okay, for our prediction. Okay, now let's try now to evaluate the model now that we have trained the model and we also have used it for prediction, for predicting our model. Okay, let's now try to evaluate the model using our metrics. So from sklearn.metrics, okay, we will import classification report and the confusion matrix. So we have the classification report. The classification report contains the accuracy and the recall, etc., etc., no? And then we have the confusion matrix. And then of course we can actually print, no? We can now print our classification report. Okay, this will be our classification report, and then we're going to have our classification report, which is classification report, and the contents of the classification report will contain our y test, okay, and of course our predictions. Okay, And then let's just copy this one and put it for our confusion matrix. This is just our label, no? And then we can use the confusion matrix for our y-test and for our predictions. Okay, so let's try to run this so that we can see our classification report and our confusion matrix. Okay, so okay, the classification report did not but actually we have now our confusion matrix, no, but the classification report did not run properly, so maybe we can actually do it separately. So let's try to remove that. So this will be our classification report. However, the format of the classification report is not that good, so we can just actually use the print function for the classification report. Okay, so let's run this. Yan, para maganda siya tingnan. Okay, so we can see the precision, no, the accuracy, the weighted average is around 80%, the recall is also 80%, the F1 score is 80%, and the support, of course, these are the number of okay, for the confusion matrix, we just paste the things, no, and then we can also look on the confusion matrix, no. Looks like we have a few numbers of false positive and negative values, no, for our confusion matrix. So definitely it looks it looks good, no. Now if you want to actually show a heat map of this, no, you can use a heat map of this. So maybe we can use the data, and we will use the confusion matrix for our y-test and our predictions, no, and then we'll use another this is for the confusion matrix. We'll use another data frame. Okay, so data frame, and we'll use the data for our data frame. For the columns, we'll use unique values of the y-test, and we'll use the index for the predictions. Okay, and then we can also put let's try to label that these are all the predicted values and the actual values, no. So the index name will be the actual, so we can use the dfcm, the index that name will be equal to the actual values, and then we'll use the column name as our predictions. Alright, and then we can now create a heat map, okay, for our data frame. Now let's have a C map, and the color of our C map the theme should be blues, and let's try to annotate so that we will have some values. Okay, and the size of the annotation equal to mhm. so this will be in a form of a dictionary. Okay, so let's try to run this. So this will be the heat map, no? So you can see the heat map of our this is just to display the array that we have obtained here, no? So we can actually put this array into a form of a data frame, okay, and use some labels to identify whether to show better show, no, in some class in some report that you would submit, you will not just submit the an array like this, no. In a paper, when you submit a paper, you would love to present it well, no, like this one, no. So definitely we already have the um, a very good prediction using uh, logistic regression. We have actually predicted correctly this uh, number of survived, or those who survived the Titanic, no, using the Titanic data set. All right. So in your activity, since there are three activities that you will do, you will have to provide a what you have to do is just to do the supplementary activities, no. You don't need to do the, no, eto I will remind everyone that you don't need to do everything again, no, from the beginning of the activity. So you will be given the notebook, but you will just copy the codes from there and implement it on a different data set. Okay, so you will find and you will use another data set. For example, for the logistic regression, you don't need to do this everything, no, because I have already shown you and I already demonstrated to you. But you don't need to do this again, no, for for the Titanic data set, because I already seen it. No, all you have to do is to look for another data set that can be applied for logistic regression model. Okay, so um, let's now have a another topic, which is the random forest and decision tree. Actually, unahin natin yung yung decision tree muna, and decision and random forest. So makikita nyo, very basic lang tong decision tree, but in order to do this, and in order to to apply this, you need to actually install some libraries, no, in case that the things that you will import will not run, you'll need to install them properly. Especially later, I will explain to you what is that, no. Now, for this, we need to we already imported the things that we need, no, above. So there's no need to import the following. So because we are actually doing it below our notebook, no. In a separate notebook, you will need to import everything, no. But right now, for example, we will import our uh, our data set, and the data set that we will import is, do we have the, let me see if I have, I think it's in my downloads, this one, the kyphosis. So I will have to copy that in here because I'm running the notebook here. Okay, so I will import the kyphosis, no. So this is the data set, kyphosis.csv. Okay, and then let's try to look on our kyphosis. So basically, kyphosis is a condition, no. It's a condition of actually we're trying to look on let's see this, no? Kyphosis is a condition, okay? It's a medical condition, and it involves the spinal cord, no? Spinal cord. And we're looking on this data set after a corrective spinal surgery, no? The age here that you're looking on is the number of months, no? So definitely ito, mga bata ito. There are 1 month old, like in this one, 2 month old, 2 month old, 128-month old, etc., etc. Now the number that you see here, okay, is these are the number of vertebrae, no, involved in the operation. How many vertebrae are involved in the operation? And the start here is the number of the topmost vertebrae that was operated on. Okay, so these are some of the identification of the data set, no, in case that you would like to ask all about this, no. So looking on this data set, we can actually check on the kyphosis, and let's try to look on using a pair plot. Okay, so we'll use the dataset DF, and we're going to use the U as our kyphosis, no, the kyphosis column. Okay, and then let's use a palette which is equal to set1. Okay, para maganda siya tingnan. Okay, so let's try to run this. Okay, it will take time depending on the speed of your computer. So you can see here the correlation between the different columns are very much correlated to one another. Okay, so we have a very nice data set, but looking on the information of our data set, we have a really small data set, no? So it contains only 81 entries, okay, from 0 to 80, and we only have the following data types, no? We have an object, whether it's an absent or present, no? Meaning after the operation, may nakita bang kyphosis o wala. Okay, present ba siya o wala. So like in this one, the 0 patient, after the operation there was no kyphosis seen, but in patient number 2, present, no, and so on. Okay, so let's try to build the model now that we have this, no. But actually, before we do that, let's try to clean first the data. Okay, actually, we can actually what we're trying to do here is that whether we can use the kyphosis as our data or the predictor, no, and we can use the age number and start for our features. Okay, so let's try to build the model now. Okay, so from sklearn, okay, that model selection, okay, we will now import the train test split, no, and then we can actually run this, and let's have the X and the Y, and we will use the Y for, you will use the kyphosis, okay, for the Y, and you will use the opposite of that is to drop the kyphosis. Okay, we will drop the kyphosis, let's try to have the kyphosis, no. Ayan. Kino-correct niya ako. Okay, so let's have the kyphosis na lang. Let's type it, and then axis is equal to 1. Okay, so that will be our the train test. We will use that for our train test split. So for x and y, and then we can also copy this. Ano ba yung madalas nating gamitin? This one, right? We can use this for this. Okay, that will be our test size 0.3. Okay, and of course we can now train for the decision tree model. Okay, so from sklearn that model selection, actually it's not for the model. We can call the model, which is the tree, no? From sklearn the tree, we can import the decision tree classifier. Okay, so that's what we're going to have, no? And then we'll equate the model in, for example, we have the model as D3 and decision tree classifier. Okay, and we will fit the model. Okay, and we will use the X train and the Y train, okay, for the training, no? So basically this is just the whole thing, no? For very short codes for creating a model, for training a model, no? So if you want to know more about the decision tree classifier model, you can just use the shift double tab here, no? Okay, so that you will know the contents of the model here, okay, or the parameters, no, that you want to include. So let's try to run. So you can see that we already fit the model. Okay, now what we want to do now is to determine how many nodes, no, are present, and what the tree is, no, what the depth of the tree, no, is it very large, is it very small, etc., etc. So using that, we can use the D3. Okay, and then we will call on the tree node. Okay, tree dot node. Okay, we will use the node count, and then of course the D3 dot tree the maximum depth, no? The maximum depth. Okay, so we will have a result of typically the node, how many nodes we have. We have 35 nodes, and the depth of the tree is 8. Okay, so you may have different result, no, because we did not specify a random state here for the values of the random state, so we may have some different values. Okay, so let's try to use predictions. Okay, try to predict our D3. So this is our D3, and we will use the X test for our actually mali yan. X should be like that. Yan. Okay, let's run it. Oh, decision tree classifier is object is not callable. Okay, kasi may mali dito, kulang tayo ng predict function. Yan, okay. So now that we have that, we can now evaluate using our metrics, no? So from sklearn again, that metrics. Okay, we can import the classification report, and again the confusion matrix also. Okay, from there we can actually print. Now we can now print our classification report, now using the values from our Y test and the values from our predictions. Okay, let's try to print that and let's see. So this is the precision report. We have 82% weighted average, and then we have for the recall, we have 0.76, no? So you will remember, as you will remember, the classification, no? This is the an information here for the precision and recall. The precision is computed as the number of true positives divided by the sum of the true positives plus the false positives. Okay? And then the recall is the true positives divided by the sum of the true positive plus the false negatives. Okay? So a model that produces no false negative has a recall of 1.0. So as you can see from our report, so we have 0.76. So definitely may mga nakuha tayo dyan na the number of absent and the number of present are in this particular ano. In terms of precision, medyo maganda, no? Ganito karami nakuha natin, 90% and 20%, this one, no? Now, if we try to use the confusion matrix, so we can just copy this and substitute this with a confusion matrix. So we can now see how many true positives and false positives, true negatives and false negatives that we have. So definitely medyo maganda yung model natin. Okay? Now in order to create a visualization, no? So let's try to create, for example, if you want to see the decision tree that we have created, no, for this one, no? So we can create a visualization of that. So we can use from IPython, okay, dot display. We will import image, okay, and then from sklearn dot externals dot 6, no, ito install nyo to. Okay? Maaring hindi to gagana sa inyo. So, kung the first time nyo lang siyang gagamitin, no? So, kasi gagamitin natin tong string IO na to. Okay? String IO. And then, meron pa kayong isang install sklearn.tree, import natin yung export graphviz. Itong graphviz na to, i-install nyo rin to, no? And kapag ka na-install nyo na siya, ang pinaka the best way on how to install this, kasi baka magkaroon kayo ng problema dito, tatanungin nyo pa ako, no? So, pag nagkaroon kayo ng problema dito, medyo mahirap i-install tong graphviz, no? Hindi siya makukuha sa simpleng pip install graphviz. So, pupunta talaga kayo sa website ng graphviz.org, download, and then sa source code packages, so pwede nyong i-download yung stable Windows install packages, and then punta kayo sa directory niya, yung ito 64-bit, and then install nyo to. Pag in-install nyo na to, okay, it will install to a path, no? So depende dun sa path na yon, tandaan nyo yung path na yon, tas buksan nyo yung environmental variables nyo, no? Lalabas ito, itong system properties, click nyo yung environmental variables, click nyo yung path, and then edit nyo, i-add nyo yung path ng graphviz, no? For example yan, ito, in-add ko na to. My graphviz was installed in my users, this is my name, and then Anaconda library bin, and then graphviz, and then click OK. And then also dito sa path na to, i-edit nyo rin siya, idagdag nyo rin siya dito sa path. Ayan, ito yun. Okay? Kahit nasa dulo, okay lang, walang problema. Basta't nasa path. Because this is the default path, no, that we are creating for, we call it the environmental variables, no. Otherwise, hindi po gagana ang graphviz nyo. Okay? So you have to look for solution in the internet on how we can run that, no. So yan. Tapos kailangan nyo ring i-import at i-install ang PyDot. Okay? PyDot or PyDot Plus. Okay? So ito yung mga ito yung mga install nyo. So medyo marami kayong install dito. Install nyo tong external 6 para ma-import nyo tong string io na to. Tapos mag-install kayo ng graph.biz para makuha nyo tong ano na to. Otherwise magkakaroon ng error, and then you'll have to install the py.dot. Okay? So next we have to create a variable features, and then we'll try to list for the df data frame, no? And then we'll use the columns from the second, which is 1, up to the end, no? Which is yun yung from the data set. Ito yung ano natin, no? We're looking on this, no? This is the first for the df. This is the first. This is the 0, no? Hindi natin sinasama yung kyphosis because this is for the y. But we are only looking on the first one up to the end, which is start, no? So pagka in-enter natin tong features natin, and of course we need to check on the features. So we will see the features are the following. So this will be our features. Okay? Now, since na import na natin yung mga required library, okay? Let's try to use IO. So this one is IO. From IO we will import string IO. It's in the bottom. And then from IPython .display we will import image. Actually na import na natin siya. We'll just repeating it. Display, and then we will import py.plus. Yan. And then of course, actually there's no need to do this, no, because we already have the we can just create a data called data is equal to string io. Yan. And then gagamitin na natin yung in-import natin na export. Ito. Yan. We can copy this and put it here. Export graph.biz. And inside that we will include our decision tree model. Okay, D3, and then out file, which is equal to .data, and then we will also include the feature names, no? Ano yung mga feature names natin? Ang feature names natin will be equal to the features. Okay? Yung age, number, tsaka start, no? And then yung parameter na field should be true. Okay? And then yung shape nung ano natin, ng mga nodes natin ay rounded, no? Yan. Okay? And of course, after we do that, we also have to create a graph. Okay? Medyo using the py.plus. Okay? That graph. Yan. Anong gagamitin natin dyan? Graph from .data. Yan. Graph from .data. This one. Yan. From .data. And then of course, include natin yung .data get value. Okay? Get value. It's a function for that data. Okay, now to be able to view the tree image, we'll create a file. Let's call it file name is equal to kyphosis, and let's save it as a PNG. Okay, so actually we're creating a file here, and then we use the function graph_write PNG, graph_write PNG, and then the file name. Okay, and then for the image So we will call on the image para mag-display siya sa atin. The file name is equal to file name. Okay? Now, we'll display it using this function. Okay? So let's try to do that. When we try to execute it, makikita nyo yung decision tree na ginawa natin, no? So this one, no? And it will take time depending on the speed of your computer, but in my computer medyo mabilis na siya. So nakikita nyo, ito yung tree. So you can also export the tree, copy the image or save the image. So you can see from here, from the start, so ito yung mga nakikita natin values up to the last values here, no? Okay? So this is a simple example of a decision tree, no? Classification. For the random forest, so let's try the random forest here. So actually we can use the same data set, no? We'll just use the for the random forest, we can actually create the model, no, for the sklearn that ensemble. So this is not a decision tree but an ensemble. So we will also import random forest classifier. Okay, and then we can create a model. We use the random forest classifier as our model, and we can actually fit the model, no? rfc.fit. Inside that, we will use the same dataset, no? X-train and the Y-train dataset. Okay, so we can now run. So this is for our random forest. Okay, so also we can use the predictions to actually use the model to predict. Okay, so we'll use the X test for the prediction, and now that we have that, we can actually now evaluate, no? So we'll try to use the metrics. So let's try to import classification report. Let's try to import the confusion matrix, and that's it, no? We can actually leave it like that, no? And then we can now actually copy the classification report code here for our prediction. So this is the classification report. It looks like the random forest using the same data set has a higher precision and recall. Okay, now for the confusion matrix, this is the code. We'll just copy it and paste it here. So it's looks like the first confusion matrix, it has 18 and 1, but here it has higher values, which is 20 and 1. So definitely it has higher, no? Now if you want to print the accuracy, score from the y-test and the predictions, so you can have this accuracy score. So okay, so maybe we can import it from here. Okay, accuracy score, and then run it again, and then we can now check the accuracy score, which is 0.84. So it's the same as this one, no? So this one has a better accuracy, the random forest, no? using the same data set has a better accuracy than the decision tree. Okay? So finally, we end this demonstration by may tanong pala dito. Sir, pwede po ba gamitin yung mga ginamit na dataset doon sa previous activity, no? It depends, no? It depends, no? If the dataset is applicable for decision tree, for example, or linear logistic regression or random forest, i-observe nyo rin, no? Kasi ang kailangan natin pag nag-logistic regression tayo, multiple features din, no? Multiple features as well as the decision tree and random forest. No, kailangan yung kung ang dataset nyo halimbawa ay konti lang yung features, tapos hindi pa siya applicable, marami pang null values. So kailangan nyo pa siyang linisin. Kailangan nyo pa siyang linisin and then bago kayo makagawa ng model. Okay? Yung question ni Legaspi, okay yan, no? Maganda yan, tanong na yan. Pwede nyo gamitin yung previous activity but it will depend, no? It will depend. Kasi baka mamaya yung napili nyo palang dataset before ay single column lang, no? Parang pang linear regression lang siya. Kasi ang linear regression okay lang yan sa single data eh. Pero pagka ganito na logistic regression, you need a univariate features, no? Multivariate pala, multivariate. Meaning maraming features ang kailangan. Okay? Any more questions?